All right, so here I want to talk about why exactly we're seeing what we're seeing when we look at ourselves in a spoon in different ways, right? So the spoon, as we mentioned, it has essentially a mirror on two different surfaces. We've got this curved surface here. The outside, right, this portion is what we'd call it's a convex mirror, right? It's kind of bulged outward. And then the inside is we have this concave mirror. It's kind of like this cave inwards. So as you guys did this, you guys should have noticed a few things about what you saw. When we were looking in the convex side, now you guys may have noticed your image is right side up. It appears a little bit smaller and also appears kind of far away, right? But it definitely appears smaller than normal. Like if I was looking in a flat mirror or a normal mirror, if you guys remember from what we did last time, I'd appear kind of like full size and I'd be able to see a smaller area of vision. Whereas here I have a very wide field of view. In fact, I can even see the laptop right here, right, my computer, and that's because the lights are coming off of this laptop. They're coming here, they're bouncing off of this spoon, and they're reflecting towards my eye. So my eye is seeing that it's not actually seeing the laptop over here, it's seeing an image of a laptop that's somewhere kind of like behind this spoon, right? So in this case, it's a virtual image, and we'll talk a little bit more about that, that my eye thinks is coming from back there, the light's coming from back there, but it's actually coming from here in the computer. Right, so that's the convex, gives us a nice wide field of view, makes things look a little bit smaller, and kind of seems far away. If we flip it over and we look in the concave side, right, you guys will notice something a little bit different. First of all, you're upside down. You may also appear a little bit kind of like strange and fuzzy, and this is in part due to the fact that when we look in a concave mirror from farther away, this is actually a real image. Right? It's not actually a virtual image, and it's a real image. We'll talk more about why this is, but it's a real image because there are actually light waves that are converging and coming together, right, somewhere in front of the spoon here, right? It's actually creating a real image, right? There are actually light waves that are kind of meeting up. So there's actually like a point where all these light waves kind of coming from my forehead are actually coming up to a point in space in front of this spoon. So it's a real image. But you'll notice the image is upside down. It's a little smaller. The field of view is also wider. So it's kind of interesting there. And then if you guys notice when you brought it really, really, really close, right, you guys may have noticed that all of a sudden the image flips right side up and it's very large, right? So I might see like a large view of my glasses and my eye, and it's right side up. You can do the same kind of thing, and this is really interesting. If you take your finger and you kind of move it close, and you'll reach a point where it's almost like you're able to touch your finger, which is cool. And then you go beyond that point and your finger becomes huge and right side up, right? So definitely mess around with that. It's kind of cool to be able to see what's going on there. So when we get close in on a concave mirror, right, the image is right side up, it's bigger, and it seems kind of closer, and it's a very narrow field of view that you have there. So why is this happening? Why are we getting these different kind of views when we look in these different mirrors? Well, let's consider it using some ray diagrams. So I'm going to go ahead and draw in here what is actually happening with these light rays. So on our convex mirror, right here I've drawn a very silly looking smiley person. And let's just look at the light rays kind of coming from their chin. So there's light rays kind of reflecting off of their chin in all directions. So I'll draw a few of them. Let's say some of them are going here, right? And let's say some of them are going up this way, right? Now the law of reflection, of course, states that the light comes in at one angle and it reflects at the same angle, right, relative to the normal slope. So if I draw a normal line on here, right, kind of, so if I consider perpendicular to the slope, a normal line might look something like that, right? So maybe that's my normal line there. And then here it's the same kind of thing, kind of perpendicular to the slope. That might be my normal line, right? So coming in and exiting at the same angle, right, what we'd get is that these light rays, they come in at this angle, and then they leave at that same angle approximately, right? So they're going out that way, and then these guys are going out about that way, right? So you'll notice that these light rays are kind of diverging. They're going away, right, from where my chin actually is. So what my eye does is my eye actually follows these light rays back, and it says, hey, so that chin must be coming from here on this one, and this guy must be coming from here. So my eye, right, actually sees the chin as being right here. Right, that's where it actually thinks the chin is right there, right? Which is kind of strange. It's like, oh, thinks that it's seeing a little chin right there. Now let's think about the like my hairline up here, and we can do this exact same thing. If we go back to there. So if we look at the hairline, right? So light's coming in, reflecting off my hair in all directions. We'll say some down there, some down there. And I could do this with all sorts of these. I could have done the same with the chin. All of those chins would have been kind of converging on this point here. Right, but I'm only doing 2 for demonstration purposes. So the same happens with my hairline. I'll look at a couple here. This one, we'll say it'll kind of like reflect off at about that angle. And this one here will kind of reflect off at about this angle, right? So my brain's going to follow those back, right, to here, let's say. And then this guy going back up like this. Right, and so we think that my hairline, or my brain thinks that my hairline is going to be right about here, right? So this would be my hair, right? So my hair, right, is all of a sudden, if this is my hair and this is my chin, my face has been kind of shrunk, right? So all of a sudden it's smaller, but it's still right side up, right? My hair is still above my chin. Right, so this is what we end up getting here if we consider what's happening with these ray diagrams. And notice this is a virtual image because the light rays aren't actually converging. Right? In real life, the light rays are kind of scattering and they're going off and spreading out, which is what gives me such a wide field of view with a convex mirror. But I appear right side up and just smaller than normal. Okay, so that's what's actually happening with a convex mirror. Now, uses for this, we can imagine bus mirrors. If you guys have ever looked at a school bus, they've got these big round mirrors that are kind of bulged out on the front. And similarly, blind spot mirrors. So if you look at like a car, right, sometimes they'll have these little blind spot mirrors, which are these little add-ons that you can get, and they just give you a really wide field of view and allow you to see your blind spot while you're driving, right? So that's really what these convex mirrors are useful for. One really cool example of a convex, it also has some concave surfaces as well. But I don't know if any of you guys have seen this before. This is a art installation called Cloudgate, also known as the Bean, in Chicago's Millennium Park. And it's just this smooth, polished stainless steel bean-shaped thing, and just gives you a pretty tremendous wide-angle view of the city, depending on where you're looking at it from. So it's a really cool art piece. If you guys are ever in Chicago, definitely go check it out. So that's convex mirrors. Now let's take a look at a concave mirror. So when you were further away in your spoon, looking at the concave mirror, right, you see yourself as upside down and smaller, right? And so let's look at what's happening here with the ray diagrams if we actually draw this in. So in this case, right, what's happening is, let's go back to black. So let's do the same thing. We'll go from the chin and we'll go from the hairline. Oops. So going from the chin, right, and once again, they're reflecting in all sorts of directions off your chin. So I could draw, multiple of these lines. I could draw as many as I wanted to, going off in all sorts of directions. But I'm really only going to focus on a couple of these to kind of simplify and make this drawing not too hectic. Right, so they're coming in at one angle based on the kind of perpendicular normal line. They're going to come off at an equal angle. Right, they're going to reflect off of this. And so that one might be going like this. This one might be going kind of like this. Right, and we'll see where these two outgoing, you'll see that these lines actually end up crossing, right? So this line coming off my chin kind of reflects that way. This one kind of reflects this way. And so my brain actually sees my chin as being right here. And so it thinks this is my chin. Move that over right here. So it thinks that my chin is actually right there. Now you'll notice already it's certainly, unless my forehead's going to be up here, it seems to be a little bit different. One thing that's for sure different is the light rays are actually bouncing back and crossing each other. Right? This is a big piece as to why this is a real image. Now if we do the same thing for the forehead, or for the hairline, right? So I'll have some hairline, some coming in at this angle, some coming in maybe, let's say, down here. Right? So the ones down here might bounce off equal angle, so maybe something like that. And this one coming in here like this might bounce off something like that, trying to do as best as possible to get that angle in equal to the angle out. And so you'll notice these guys cross right here. So if we draw in where my mind sees my hair as being, it sees my hair as being right there. So we'll notice, because of this, all of a sudden, my hair is down below and my chin is up higher. They're also smaller, right? So I see myself as flipped upside down and smaller while looking in a concave mirror. Right, now we could do the same thing as I move away. If you notice, as you move away, you get smaller and smaller and smaller, right? And that's because as we move away, the reflections that are going to come are going to make these two closer and closer and closer together. But it's always going to be flipped, right? And so unique things about a concave mirror when you're farther away, right, is that, number one, the image is upside down. The image is actually real, and the reason why is because these light rays are actually crossing each other. Now, I have in here a little video I want you guys to watch from Mr. O'Keefe. He did this great demo. I didn't have the materials to access it, so I kind of used his. But it's this great demo talking about why that image is real and why it's important that those light rays are crossing, and why that's different from other types of mirrors. Right. Uses on this, you can use it to focus light rays. So for example, headlights and flashlights, right? They actually have right in here a little spot around that light, which is essentially a reflective concave surface that helps direct that light beam forward. Another example is in satellite dishes. So for example, anytime that you see like a satellite dish, even just the ones that are on your house, right, they're actually a concave surface that is not actually reflecting, in this case, visible light rays, but it's actually reflective to other things like microwaves and X-rays that allow us to focus those rays to a single point so we can actually capture images or data using those, which is kind of cool. So that's a use there for these, a big use for these concave mirrors. Now you guys may have noticed with the concave mirror, as you get in really, really close, so as I look in really, really close to my spoon, right, the image actually flips. This is an example, you guys will see this in makeup or shaving mirrors, kind of like this. They magnify. Sometimes you'll see these mirrors and they have one side is just slightly concave, so it's slightly curved inward, and the other side is totally flat. So you have the option to look at yourself just like in a normal mirror, or you can flip it and look in this concave mirror close in, and your face is magnified, right? It's kind of expanded. And these are useful if you're like shaving or applying makeup, because then you don't need to get so close, or you can be a little bit further away and still get really good resolution. So if you think of how that works, kind of doing the same thing, go here. So we'll stick with the same thing. We'll do the chin, a couple of lines off of there, right? And those are going to be reflecting off approximately like that. Oh, I might need to make myself in a little bit closer here in order for this to work. So let's go ahead and I will select all these guys. Let's bring myself in real close. Okay, perfect. So now going off the chin, all right, we'll have a couple. Let's say one here and one here. All right, and you'll notice this one coming in, it's going to bounce off at about an angle like this. This one's going to bounce off at an angle about like this, right? And what's happening is that these light waves actually end up diverging, right? So they don't, the outgoing light rays don't actually catch each other, right? But my eye follows them back, and then let's see. So it follows this one as going here, and this one as going here, and eventually those would cross, and you'd see that my chin would be way down here, but it would be like way down here. And similarly with my hairline, right? If that's coming in like this, and it's coming in like this, these ones will bounce off about like that. This one about like that. And similarly, following those back, right, you'll see my hairline as meeting somewhere way back here. So my hair, right, ends up being somewhere back here, and my chin ends up being somewhere back here, and my face appears huge, right, in behind the mirror. So that's actually how these concave mirrors work when you get in really close. That's why they appear so big, right? So that's how we can use kind of these ray diagrams to understand what's happening there. What I'd like you guys to do at this point in time is hopefully you guys get a good feeling for this. I'd like you guys to kind of fill out, I've got this little table for the image descriptions for these different types of mirrors we've looked at so far, if the image is real or virtual, some useful applications. I want you to watch that little video by Mr. O'Keefe. It's really cool. And I've just got a few conclusion questions I want you guys to check out. One is a video about a solar death ray, which is really cool. This guy actually just took a satellite dish and he covered it with a bunch of tiny little square mirrors that it acts as one big concave mirror. And you can do some pretty cool stuff with that. Yeah, it's really awesome. Essentially, you're just creating a single focused image of the sun, So think about what that means and why it might be a death ray. And the last thing I want you guys to do is just kind of go outside to a car and check out the passenger side view mirror. And I want you guys to think about what that says and why that says that. So hopefully if you guys kind of review what our goals were today, hopefully you guys feel pretty good about that. Hopefully life is still great. You guys are hanging in there awesome. I definitely miss you guys, and I will see you later.